Hey, this is Joe, Graybench Electronics. Welcome back to the bench. So I've done a couple videos like this where I have some searches set up, saved searches in my eBay account for old vintage electronic components like germanium transistors, old op amps, old diodes, stuff like that. And every once in a while I come across a listing that looks interesting to me and I'll buy it. And I thought it'd be fun to just sort of do like a mail day, something to break up the pedal teardowns and amp builds and pedal builds and whatnot. And we'll just have some fun, look at some old electronic components, and who knows, maybe we'll find some useful parts in here that we can actually use in a pedal build somewhere time down the road. We have the package here. I don't remember, I believe this one had some old looking transistors, some like T05, potentially germanium transistors, some old metal can op amps, and some old looking through-hole diodes. It looked like a mix of used and new, and I believe I bought this for, I bought this for 26 bucks. And it was $6 shipping and about $2 tax. So it ended up being about 34 bucks for everything. I have my trusty DCA 75 semiconductor analyzer. So let's go ahead and just crack open the box, see what happens. Not the most sturdy of packaging here. This is definitely like a inside box, not a shipping box. Good rule of thumb, if your box doesn't have the seal, let me just see if I can give an example. There should be a seal on any shipping box you use that shows that it's certified for shipping. And you'll see here. So it actually tells you it's certified for 200 pounds per square inch for bursting tests, and then size limit 75 inches, gross weight limit 65 pounds. And the insurance companies use this information to determine whether or not they'll pay out on an insurance claim if something happens to your box in transit. So if the box doesn't have one of those seals, the insurance company may not pay out for your claim. Just FYI. Got a bag of old looking diodes there. And if you're wondering, yes, that is in fact gold. Gold is used as a plating material for electronics because it has very good conductive properties. In fact, I believe it is the most conductive metal. Am I imagining that? So gold isn't the most conductive metal. I was wrong about that, but it's highly resistant to corrosion. So the combination there of high conductivity and resistance to corrosion makes it desirable for industrial applications where something will get installed and then not touched again for potentially years. The most conductive metal, if you're curious, is silver. So we've got a pile of transistors here, and we do have some op amps. I can tell there's definitely a mix of new and used going on here. There's a lot of unmarked transistors that I'm seeing so far, which could mean a variety of things. It could mean that the bad side of it would be stuff that didn't pass muster at like a semiconductor manufacturing. They used to be sold as like rejects in old electronics catalogs. Or they could also be like house number parts where a manufacturing plant would make a huge order for parts and not have the semiconductor manufacturer's branding on them. You can start to kind of paint a picture of what you're getting, because I'll see a bunch of transistors like this where they'll have these red dots on top, which usually when you put paint marks on transistors, it's going to indicate, it depends what it is. If it's a BJT transistor, it could be gain sorting. So you'll see red dots on other transistors indicating, like if you've ever seen the Analog Man NKT red dot, that red dot means a couple of things. It indicates the collector, so it's a specific spot on the transistor. In this case, that's not what is happening, at least I don't think so. Probably not. And it's also gain selection, so sometimes you'll see a white dot or a red dot that could be gain sorting. It's not always, sometimes it's just indicating the collector, but often they'll use a paint dot like that to indicate a spec of the transistor. All right, I'm going to sort this pile here into components that seem to be related to each other, and then we'll jump right back. All right, so I got the parts here sorted into rough piles. So these transistors over here have a red dot on top like so. A small handful of these transistors have 2 red stripes. These are 6-pin in a TO5 shaped package. It might actually have a different designation, which are probably dual transistors, like matched transistors. Over here, these transistors have a black dot on top. Over here, these are just miscellaneous. You can't really see them. They're like otherwise unmarked or miscellaneous TO5 or 3-legged components. We've got a couple 8-legged, a small pile of 3-legged unused or new old stock components, a much larger pile of used small transistors or whatever 3-legged components, and then a very tiny pile of very used and dirty diodes that I'm just going to throw away. Sometimes with these components, or with just buying like used or electronics lots like this, you got to know where to spend your time. And old, dusty, crusty diodes that have very short leads and are very ugly and soldered, they're just not worth your time. These used transistors are debatable based on how short their leads are. It would be difficult to use these in anything, but I will generally just take these and throw them in a little baggie and then put them in a pile with other used transistors for a even rainier day than it is today to deal with. So that leaves us with these piles here. So let's start with the big pile of transistors. Let's move this stuff aside and see what the DCA75 tells us about these. All right, so these are the transistors with the red dots on top. Let's just clip one in. All right, so this says PNP silicon BJT and no leakage, 43 HFE. So pretty low gain as well. Let's try another one. 51 HFE, silicon, PNP. The hope is obviously that they're germanium because germaniums are more rare, difficult to come by. But silicon transistors work just as well, if not better, than germanium in basically every application. It's really only in like old vintage electronics restoration or basically guitar pedals, like fuzz pedals, where people actually seek out germanium transistors. Very specialized applications. Germanium transistors do have unique properties, being essentially made up of 2 germanium back-to-back diodes. The very low forward voltage or voltage drop of the base emitter junction can give you reasons to use germanium for very specialized cases. But generally speaking, unless you specifically need that low forward voltage of germanium transistors or germanium diodes, silicon transistors are better in pretty much every other way. Low gain silicons are good to have, at least some, because they're not that common. Most of the silicon transistors you find today are at least 100 HFE. Okay, so yeah, pretty confident that these are all PNP silicon. Oh, that's interesting. This is a silicon transistor, and it has 69 microamps of leakage. So that's far too much for a silicon transistor. Of course, with a lot like this, you would have to test every transistor. You never just take one out of here and be like, yep, that's good, and throw it in a pedal, and then definitely not sell it to someone. Okay, so these are unmarked PNP silicon. These are the black dot transistors. NPN silicon BJT 104, NPN 107. Okay. Yeah, so these are all silicon BJTs as well. All right, let's look at these ones. These are small pile of transistors that have 2 red stripes on them. PNP silicon, HFE of 63, no leakage. So 63 is a little bit higher HFE than the red dot ones we looked at so far, so these could be like a little bit higher gain, and 2 red stripes to indicate that. PNP 62. That's showing 75 milliamps of leakage as well. These are the 6 lead devices, so it's 6 leads coming out, sort of 3 on either side. And whenever I've tested these, it's been matched transistors, like a pair of transistors. So we'll test one side, see what happens. And that's reading a NPN silicon transistor. Switch to the other side, and NPN silicon HFE 96 are pretty quick gain. So yeah, probably dual transistors in one package. When you don't need a ton of power dissipation, you can do that. And because they're on the same wafer in the same package, they tend to have similar specs. All right, so we got some small TO92, that's the black package, and the top hat, I don't recall what the package designation is for those. But luckily these are more modern, so we can just look at a part number. So these are 2N3906, which is a PNP silicon BJT from Motorola. This one is marked MSD 6150. It's 3906, 3906, 3906. These are nice to have because they're a drop-in ready replacement for any PNP germanium fuzz face, or really any germanium fuzz pedal. You can just, if you want to try silicon in that same pedal and you have socketed transistors, boom, 3906 is going to fall right in a good gain range for that. This is a MPS 2712. I'm not familiar with that part number, so I'll write that down and hopefully find a data sheet. The MS might be Motorola Semiconductor. A lot of companies will do that where they'll put their own designation in front of the part number. So these white ones are not marked. So let's test one of these. So it is silicon, but it's JFET. It's an N-channel JFET. VGS off is negative 3.15 volts. IDSS, do we have IDSS? Yeah, IDSS is 9.11 milliamps. So no reason you couldn't use this in a guitar pedal. Absolutely could. At negative 3.15 volts, you're not going to get a lot of gain out of that. So if you compare that to a much more common use JFET like the J201, the J201 has anywhere between negative 0.2 and negative 1 pinch-off voltage, which is, they call it VGS off. That is a high enough voltage, so positive enough, not negative, that your guitar signal can actually cause clipping just on the input signal itself. A guitar output can put out half a volt for like a humbucker with a big chord strum. So that's one of the reasons why the J201 is so popular for pedals, is because of the very low pinch-off voltage. These have a higher pinch-off voltage there, as you saw, but that doesn't mean they still can't work as amplifiers. They absolutely can. You're just not going to get the clipping you would get with a J201. Here's another one of those, negative 2.72. IDSS is 8.76 milliamps. So absolutely would work in like a JFET boost pedal, like a Tim Esco, what's their name? Escobedo? Sorry, I can't remember their name. Their Duende boost. This would be a great choice for that pedal. So that's cool. JFETs are always good to have, especially through hole. Let's have a look at some of these multi-pin, these 8-pin packages. So this is, I'm not going to know these. So that is the S, which I think is Signetics. Yeah, there you go. So that's an S 7646, which is probably the date. So 1976, 46th week maybe. And the S, I believe, is Signetics. And that's a 150677. Probably a house number. This one, interestingly, it actually has the same part number. Definitely a different manufacturer, different package, but it's got that same 150677. And conveniently, this one is marked LM201A. So we're going to put that right next to there. That logo is Siliconics, and that's a DG200BA. And this last one here is completely unmarked. All right, so there are those transistors all sorted out. These little ones with the used transistors, that, like I said, that'll be for another day. And we looked at what these multi-pin ICs most likely are. And then these will just go into storage with my other vintage whatever transistors. All right, so there is the haul from this eBay vintage electronics find. I hope you enjoyed the video. However, all three of you left watching the video at this point, I'm sure. I appreciate you. If you want to see more videos like this, let me know in the comments. If you have any questions, feel free to leave them down there. If you enjoyed the video, then also feel free to subscribe and hit the like button and hit the notification bell so you know when I make a new video. I am Joe from Gray Bench Electronics. Thanks for watching.